So today we're going to be talking about continuous verification. Some of you might know it as chaos engineering, which is what it was previously called before everyone realized that's a terrible name and nobody's going to sign on to doing it. So the whole industry decided we're going to rename it as continuous verification. And I'll tell you what it is. But first, a little about me. I've been doing this for a long time. I've worked at Disney, I've worked at the New York Times, I've built my own things. I've broken many of those things, and therefore I know how things fail in production, because it's usually me causing those problems. I prefer Vim as my text editor. Don't kill me. And I can usually quit it, but oftentimes I just have to force quit the entire program because, at some point you get frustrated and you're just like, nah, I'm good with this. And this is a true story. My worst production incident, I put rmrf dot on a cron job that ran as root when I thought it was going to run as my user. There were 4 WordPress websites being hosted by cPanel, and every 3 hours the entire server got wiped. And I had to call the offshore tech support, and they ended up, thankfully, re-imaging it from an image from a week before I had made the change. Otherwise, that could have been bad. Okay. So basically, I presented this to my friends, and they said, you need an agenda slide. So here's the agenda slide. There's 3 things. I'm going to tell you about the problem we're facing. I'm going to provide a solution, not the solution, but a solution. And then I'm going to talk to you about applying it and how you can actually do this in your organization, tomorrow or whenever you go back to work. So first, the problem. Everything fails all of the time. Now this is Warner Vogel's, Amazon's CTO. Amazon, the company that you're expecting, a lot of you and probably most people at this conference who aren't using GCP are probably expecting this company to keep your servers up. And this company's CTO is telling you that everything is going to fail. But the reality is, everything does fail all of the time. For example, Amazon, US East 1. If anyone is familiar with Amazon, US East 1 is where everybody hosts their stuff, including Amazon. So when US East 1 went down for 7 hours, almost all of Amazon was down, to the point where even airlines were being impacted. Disney Plus. Why would Disney Plus be impacted by a single regional outage in AWS? Who knows? Well, it was. Netflix. I didn't even know Netflix still ran in AWS, but apparently they have some dependency. And of course, the contributing factor was an intentional change, as it usually is. Facebook. I'm sure a lot of you remember this from last summer. Facebook went down for 6 hours. Again, intentional change. It was DNS. We're all so surprised. It was so bad that they couldn't even get into their server rooms to reboot the servers manually because their door scans relied on the Active Directory servers that also used Facebook.com as their DNS, so those were inaccessible too. Again, intentional change. Always an intentional change, right? It's never just something breaking. So as site reliability engineers, pretty much our primary driving directive is to improve the reliability of our services. We are there to help the application teams make sure that their applications run all the time. We do a lot of things to achieve that. We prepare for things degrading. We build caching, we build CDNs, we distribute our content everywhere. Oftentimes we're running multiple levels of networking just to make sure that if one problem happens one place, we can route around it. We also prepare for failure. We build redundancy into every layer, and we build ways to accommodate for things like auto-scaling that we can't predict. We're going to get traffic. We want it to automatically spin up servers. My favorite thing is like multi-region disaster recovery instances. It's like if we were civil engineers instead of software engineers, that'd be the equivalent of building a bridge and then building the same bridge right next to it, but no one's going to use that other bridge unless the first bridge falls over. And that's what we do. We literally will run 2 full copies of our apps just to make sure. And of course, all the best laid plans of mice and men. If something goes wrong, we prepare to respond. Capturing logging, capturing monitoring, hooking all these systems up to the point where if something does go wrong, someone gets paged, and they should know right away what happened. And when we think about all the things that we do as site reliability engineers versus the application developers, the reality is the apps are regularly tested. We have unit testing, code scanning, vulnerability scanning, all these things we put into our CI pipelines to make sure that the application is regularly verified. But all this other stuff that we as site reliability engineers build, we really rarely test those things, right? We usually only test them when they're needed. There's a production outage we need to restore from a backup. Let's hope the backup system works. Let's hope our disaster recovery plans work. When was the last time that failover was tested? Oh, it was last time the site went down, of course. So I want to do a quick poll, and I know that, hey Dylan, I know that asking the audience to participate is like a gimmick in speeches, but I do want you to just raise your hand if you or someone on your team is responsible for one of these things with the question mark next to it. One, okay, a couple people, yep. Okay, now put your hand back up if you've tested those things in the last 12 months. We got one out of all those people. Okay, keep it up, keep it up. Was that test intentional? Okay. And the last question, would you bet $100,000 right now if I went and broke something that your disaster recovery plan would work? 100 grand right now. All right, we got one. That's pretty good. Normally, I expect 0, so yeah. So the real question is, like, how do we know all these other things that we're constantly building and constantly working on and constantly expecting to protect us against failure, how do we know they're actually going to work when they're needed? And that is where continuous verification comes in. So Nora Jones and Casey Rosenthal are like the godparents of this concept of chaos engineering, and they would say this big thing about what CV is, but what it comes down to is it's unit testing for the stuff that site reliability engineers build. It's unit testing for our stuff. It's testing all of our code with the same level of regularity and precision that application developers test their applications. It's not a crazy idea. It's just most people hear the term chaos engineering, and they assume that we're going to just break stuff on purpose, and that's how it goes. But that's not how it is. And I'm here to give you a better way to do this type of testing. So just to give you a little background, chaos engineering started at Netflix with something called Chaos Monkey. And now Chaos Monkey is true chaos engineering. It would literally just turn stuff off in the middle of the day with no warning. And the expectation is that the services and systems would respond to that failure. As Netflix got better at what they were doing, they introduced Simian Army, which would do the same thing, but all across their entire infrastructure, doing way more than just turning off servers. It would interrupt network connectivity, take down databases, all sorts of stuff. And then basically between 2011 and 2020-ish, the industry grew very slowly. Very few companies actually adopted this approach, even though, Netflix is doing it, and every company thinks they're like a Netflix or a Google, so like, okay, we got to do this too. They didn't do this with this. Not like Kubernetes, where everybody is like, oh, Google's doing Kubernetes, so we got to do that too. But in 2020, AWS added chaos testing to their well-architected application framework, which is what a lot of companies follow when they're designing applications. So it is something that the industry is slowly coming around to. And I'm guessing the name chaos engineering didn't really help that. So with continuous verification, we can answer things like, do my backups work? Can my application survive hardware failure? Have any recent changes affected our ability to scale? Things like this where you kind of assume they're going to work, and when they actually happen, you hope they're going to work. But maybe we can verify those ahead of time. And the way we're going to do this is we're going to treat it like a scientific hypothesis, which some of you may have remembered if you remember your high school science days. Scientific hypothesis, very specific and testable, and that is what we're going to be working on today. So we're going to do 3 things. We're going to define our test cases. We're going to think about ways to run these experiments so that when you go back to your companies, you'll have some ideas of how to actually execute them. And then we'll talk about how we're going to measure them so that you know that what you're doing is actually working. And so we're going to start with defining. Now, your first instinct of defining how is one of these kind of chaos, we'll call them chaos tests, right? Because we are breaking things. Your first instinct is, I just want my application to stay up. But the reality is we really need to define how your application should respond. Not just it should stay up, but what should it do in order to stay up. And so you should be asking yourself, how should it work? How do you expect it to work in these different conditions? So here's what a unit test looks like. For any of you who aren't application developers, who don't write code regularly, with a unit test, you take a function, you give it some inputs, and you expect certain outputs. So if you have a function that adds 2 numbers, you'll give it 1 and 1, expect 2. You give it 2 and 1, expect 3. What happens if you pass a null value? Who knows? We'll find out. And there's 2 benefits to doing this in application code. 1, you verify that your functions work the way you expect them to. You validate your business logic within the function. But the second reason is regression testing. If you're constantly changing things and constantly deploying those changes, how do you know that one of those changes didn't break something else? And so unit tests in application code help identify when something has gotten worse. And with continuous verification, we're kind of doing the same thing with your infrastructure and scaling and all of that stuff. So here's what a continuous verification, which we'll just call it CV from here on out, CV test case looks like. Same as with a unit test. You have a target, which in this case is infrastructure. You have conditions that impact that target, and then specific behaviors that you expect to happen when those conditions impact those targets. And now we're going to go through this kind of slowly so that you understand how to identify these things, and then you can take this back and actually apply it to your actual infrastructure when you get home. And we're going to start, I don't know why that slide only has animation, but we're going to start with the target, and we're going to ask, where can things go wrong in your application? Now, I'm sure that some of you have known troublemakers, right? There's probably that one service that always falls over, and nobody knows how it works, and every time it falls over, you just reboot it, and it works. So you're just going to kind of do that forever. But for a lot of people, they probably have never experienced significant enough incidents or regular enough incidents to know, like, this is a problematic resource. So what we're going to do is we're going to draw a very simple, oh my God, these animations, a very simple architecture diagram. And I'm not talking down to like, we're running this image on this server with these networking conditions. It's really just the logical network diagram, or a flow diagram, right? It's like what things talk to other things. Right? You have this auto-scaling group. That could be 1,000 servers. It doesn't matter. It's a bunch of servers. You have this like Redis cache. Who cares if it's Redis? It's a cache. It's something that every server relies on, right? So you just kind of want to lay this out so you see all of the risk points, all of the things that could fail in your system and how they talk to each other. And then you're going to go through and you're going to identify those things. You're going to identify each individual component. So you'd say like, oh, I got a database here with a read and write replica, got this auto-scaling group, and then I got these dependencies between them. So you say, oh, my servers depend on this cache, my servers depend on these databases, and then, of course, there's always these spooky services that nobody knows what they do or where they are or who owns them, but they are somehow critically important to your application, and you just don't want to touch those, but you at least want to identify them because they are a risk to your system. So now you have a bunch of targets, basically. You have a bunch of individual components and a bunch of dependency pairings that you just identified. So now we need to think, what could go wrong with those things that we just identified? And this is where it gets like really wild, and you can go pretty deep into it, but we're going to try to take it from a surface level and start easy. And to do that, we're actually going to use what's commonly known as a risk assessment matrix. This is used in almost every industry, not just software. And the idea is we are mapping the likelihood versus the impact of those conditions. And we'll go through and I'll show you some examples. And as we go through, you'll see that some of them are very high risk and some of them are very low risk. And this prioritization exercise helps you identify what things you should work on first, what things are going to have the most value to your organization, which is how you get people to sign on to this. So some examples of what these conditions might be, the things we've all heard, things that break, things that go wrong, et cetera, et cetera. My favorite one being when a key engineer leaves the company and their credentials are all deactivated at Friday at 5 p.m. And nobody knows why Active Directory decided to do that, but it causes a really hellish weekend for whoever's on call. And if none of these things are scaring you enough, go to the Void incident report, and you'll stay up for weeks because it's really scary what kind of things can go wrong even in the biggest companies. So some examples of this. Look at the simple dependency graph I just drew you. I mean, like cert expiration, right? That happens to all of us. Certs expire. They just naturally expire. And somebody's job somewhere is to renew that cert. And if they don't, cert's expired. Lots of problems happen, right? But then something like resource exhaustion, which can happen at almost every layer, if you consider it on your caching level, which every service uses, that's a big problem. That's a red, high-risk problem. But the same resource exhaustion on a server might not be a problem. If you have 50 servers and one dies, life goes on. So that's a green, right? So you go through and you kind of identify, using this process, which risks are the most risky to you. Which things are the most value for you to prevent? What things do you not want to happen? And frankly, if you're doing this with a product manager or somebody who's not technical, you'll probably end up with a lot of really high-risk things because they'll hear, oh, resource exhaustion, scary, red, right? Credential expiration is scary, red, but resource exhaustion is not. Network latency, scary, but not red. But if you have too many of these high-risk things, give them numbers. Then you can actually order them to the point where you'll have the most valuable, most risk conditions going way down to these green ones, which you probably don't need to do. Whatever. If it's a 3, it doesn't matter. But you'll want to start with those 9s, and you will have 9s and probably 10s. So now you have a list of conditions and the targets that those conditions can occur to. So we're going to look at what you expect to happen when that condition occurs on that target. And we're going to use the scientific hypothesis we all know and love, if-then, essentially. And so we're going to go and basically do like a Mad Libs, where you take for each target you found and each condition that you identified, and we're going to start just with the one that is a 9, so the highest risk thing. What do you expect to happen? What is the desired behavior? So some examples of this. You think about what questions you're trying to answer. Will my service self-heal on hardware failures? So you might say, like, if an instance fails in my auto-scaling group, I expect a new instance to be added. Maybe you want to know, will my service scale? So if I get unexpected load, I expect new instances to be added. Does my backup plan work? Does my disaster recovery plan work? Will my failovers actually work? And of course, these don't have to be chaos. They don't have to be failures, right? So if latency is high, which can just happen, you might want to make sure that your paging system is hooked up. So it's not just about breaking your application and seeing if it survives. It's actually making sure that all those tools that you've integrated as an SRE to make sure your systems stay reliable, making sure they all work and under the conditions they're supposed to work. So now we have a bunch of basically test cases. And like I said, I would start with that highest risk condition first and work your way down. Just start with one, make your life easier. And we're going to figure out how to actually trigger that test. And to do this, you want to ask, how do you create the conditions that you expect to trigger that behavior that you just defined in the previous step? And I'm going to go through from the easiest and lowest investment ways to the highest investment, highest return ways. The first one is manually. Now, the internet is now calling this ClickOps, which means going into the console and clicking things, which is how we used to do things, so I don't know why it needs a new name, but you can still do that. You can actually create these conditions where it's something Amazon wants. Sorry, also, I use Amazon, obviously, so everything's going to be an Amazon example, but it's things Amazon expects you to do, like rebooting a server, changing your environment variables, throttling your Lambda concurrency. These are things are meant to do a certain thing, but if your app isn't expecting that only one Lambda can run at a time, maybe a queue will back up, right? Maybe this Lambda is reading off a queue, and if you throttle that to 1, what happens to your application if it's expecting 1,000 Lambdas to be running at any time? What happens, right? Rebooting servers, that's really fun. Go reboot your database server, see what happens, right? I mean, that is something that happens all the time. Amazon will just reboot your server for fun if it does maintenance. How do you know your app's going to work when that happens? Well, test it ahead of time. Now, the beauty of these like per target attacks, one, it's free, obviously, really low effort. I mean, you can just get in there and run one test once, and if you hate it, just never do it again. There's no investment. And automation is possible, although it's manual, and we'll get to how to do that after we talk about a couple other options. And of course, the power is very limited. You're limited to what Amazon wants you to do, what you're allowed to do in the console, which sometimes will work, but sometimes you also want to push it to the next level and see what happens when unexpected things happen. So now we're going to move on to the native tools. And I love this section because most people don't realize that at least Amazon, and I'm assuming the other cloud providers, offer a really powerful tooling to do things that you should never be able to do, specifically Systems Manager, which lets you execute commands on your EC2 instances without SSHing, which means you can automate that, right? This is Amazon running commands on your instance using their agent. So you're not running your own scripts. Your security people will be happy. But what's really cool about this is you can secure it with IAM rules. You can limit it to certain targets. You can do all sorts of the normal things you would do in Amazon, you can do with these. And I don't know if you can really see, but you see there's a chaos engineering section. And in fact, Amazon offers a bunch of out-of-the-box chaos engineering exercises. For example, spinning up disk to 100% usage, filling your disk, filling your memory, using 100% of your CPU. All these things can be done without you ever touching a server through Systems Manager. So it's actually super powerful. And most people don't realize you can do all these things without ever actually accessing your server. And now, recently they released this thing called Fault Injection Simulator, which takes those documents, those SSM documents I was talking about, and builds like a layer of control over them. And what this allows you to do is design these tests using these documents that I told you about, and then also monitor your application so that if the test causes a problem, it automatically stops. And you can do really cool things with this that you can't do with any other tool that I've identified, including simulating failure on Amazon services. So you can say, so let's say your app uses S3 and Dynamo for a bunch of stuff. You can actually simulate packet loss or complete network degradation just for those services, just for one IAM rule, which means you can target your application running in prod, let's say, and simulate as if Amazon went down, but not touch anything else in your account. Not touch your code, you don't need to touch your containers. Amazon will do it all for you. And as with other Amazon tools, it's kind of hard to configure the first time. There's a lot of weird putting JSON in input fields. I don't know why they do that, but super powerful. And once you have it configured, it just runs by itself. And just like with the individual targets, it's free. You can just run one and quit if you don't like it. So really low investment automation is possible, but you get a little more power out of this. It can do things that you can't do through the console. So you get a little extra oomph out of that. Now we get to open source, and this is, as you're progressing through your journey of implementing continuous verification in your company, at some point, these little one-off attacks are just not going to be enough. You're going to need something a little more. And there are a lot of open source tools that do this for you, and they're really good. So just the ones on the screen, Chaos Toolkit, awesome tool, can attack every known provider, has a bunch of different modules. You can write your own modules. It's all written in Python. It's a great tool. And it can do a lot of integrations, so it can send notifications and stuff. It's awesome. Litmus used to be free. Now, well, I think they still have an open source version, but yeah, they're good too. And Chaos Monkey, which we talked about. Now, Toxi Proxy is from Shopify, and it's good for simulating network failure. So you actually set up a Toxi Proxy instance, you route all your traffic through it, and then you can degrade traffic, cause latency, cause packet loss, all sorts of things through that proxy. It's really easy to use. And then K6 is an awesome load testing tool, if you ever want a good load testing tool. FireDrill over here is the tool I'm working on. And FireDrill basically takes all of these and more and runs them automatically for you in your account, and automatically collects results and normalizes those results. So a lot of the glue code that you would probably are thinking in your mind, I'm going to have to write so much glue code for this, a lot of that stuff can be gotten rid of with FireDrill, and I'll talk to you a little more about that at the end. So if you're using Kubernetes, I didn't realize there was going to be so many Kubernetes companies here, but if you're using Kubernetes, there are also Kubernetes-specific ones. And these are probably the best I've ever seen, because these, if you're running Kubernetes, you have access to everything. You have access to the underlying operating system. You can control the servers. So you can obviously cause a lot of problems if you give one of these tools administrative access to your clusters. I haven't used the Chaos controller yet from Datadog. That's brand new, but apparently it's kick-ass. So I would definitely give these a try if you're using Kubernetes. Ooh, too far. So the beauty of open source, again, it's free, it's community maintained, you can kind of expect it to work. The initial effort is a little bit more, right? You have to run the tools, get used to the commands, figure out how do I give it credentials, stuff like that. Some of them are command line tools, some of them are configuration driven, stuff like that. So you gotta figure all that out, whatever, it's kind of a pain in the ass. But automation's possible, and you get a lot more power. These are really powerful tools, and because you are deploying them as an administrator, you can do really cool things with them, like route all your traffic through that Toxi proxy, what you couldn't do if you were just using Amazon tools. They don't want you proxying traffic in their network. So, I keep saying that automation is possible. And what I mean by that is anything that's a command line tool can be automated with a script, right? So if you just want to get running these things and start automating these things, write a script. All of these are essentially command line tools. So all you need to do is write a bash script or whatever you want to use, and then you can run that script manually, locally, if that's how you want to do it, or as a build step in your pipeline. So if you're using GitHub Actions, for example, I know everyone's really jazzed about GitHub Actions, you can do that. And then what's really cool about writing your own script is you can send logs, send events, send metrics to your monitoring, and alert if something goes wrong. So basically all the concerns that you would have to do manually, because you'd have to be staring at your application while it's running, you can do in your script. And it's quick and dirty, and it's not going to be scalable, but if you just have one application to test, no problem. It's a great solution. And if you want to automate that, you can do that too. A lot of people don't know that Lambdas can now run Docker images. So any script that you can write on your local machine, you can run as a Docker image, and you can put that on a Lambda. And then you can trigger that Lambda, either through your pipeline or through a scheduled cron job. Boom, you got yourself automated continuous verification tests without any tooling whatsoever. And obviously, if your environment's different, you can probably find a way to do this, or of course, just run it manually. It's a great start. Now, at some point, you're going to get, well, at some point in your journey or right away, you're going to realize I need something more powerful than a bash script that runs in a Docker container. And so there are SaaS products that do this. The three major players in the industry are Harness, which just bought Litmus, Verica, which is Kubernetes specific, and Gremlin, which is kind of the top of the line tool right now. And the beauty of SaaS products, I mean, obviously they cost money, a lot of money sometimes. And there's a little bit of effort, like there's like salespeople, sorry to any salespeople who are hearing this, but there's like salespeople you got to deal with, and it's like a high-touch thing and whatever. But once you get set up, super high automation and super powerful, right? Like these things will automate out of the box. They'll connect with your existing tools. They'll have integrations. You click some buttons, and boom, you got yourself a fully fledged platform here to do this type of testing. But the cost is prohibitive for a lot of people. So those are a bunch of different ways to run these. If you have a specific configuration, or like I want to test Redis, for example, there's probably open source tools out there that just test the thing you want to test. So do some Googling before you pick anything. So I have a bunch of, so you know what you're going to test, you know how you're going to test it, but now we need to make sure that the test actually works and that whatever you are testing passed whatever conditions you expected it to pass. So you're going to ask 3 questions. Did it work? It being your system. Did it work correctly, which are 2 different questions almost all the time, and did anything else go wrong? Really, the beauty of this type of testing is not just verifying that your stuff works, but that nothing else breaks when these things happen. Because you'll find very quickly that dependencies you didn't realize were dependencies are actually critical dependencies, and when you break them, a lot of things go wrong that you would have never predicted in a million years. But this is a good way to figure that stuff out. And so we're going to turn to our existing monitoring tools to do this. People, when I always talk to people about this, they're like, well, how do you know that nothing else is breaking? And my answer to that is, how do you know now that nothing is breaking? The answer is you have monitoring. If you don't have monitoring, then just get rid of all this. You have a lot of work to do before you get to this point. I assume you have some kind of application monitoring. And if you don't, just use the native ones. If you're running in Amazon or GCP, and I assume Azure has something like this, there's native tools to do this. There's native logging, there's native monitoring. You can set up alerts, you can set up dashboards. And if you log as JSON in your application, you can actually use those metrics. You can actually produce your own metrics in your logs. So there's no excuse not to be monitoring your application at this point. There's tools to do it. But there are so many metrics. And that's really where people, I think, get a little confused. Is you look at this list of metrics in like the Amazon Metrics Explorer, and there's just like hundreds and thousands of them. So we're going to go through and basically for each test case that we define in the beginning, we're going to figure out which metrics we need to actually test that thing. So for example, before we just had, if an instance fails, a new instance should come up. But the reality is, if one instance fails, one instance should come up. If 2 fail, 2 should come up. And you can write multiple test cases against the same exact condition by just changing that number. And same thing with like error rate. It's like, well, at what point do we expect our system to start reacting, right? An error rate of 5% could be anything. But an error rate of 10%, something's wrong. So you might expect something to happen at that point. And along the same lines, once you get more advanced, you're going to want to define what would you consider a failure, right? Like, what if it takes more than 30 seconds for your instance to come up? That could be a huge problem for your application. Or what if your latency on your home page, your API, spikes while these things are happening? You might not want that, and you might be expecting that your system is going to respond fast enough that that latency doesn't go up. So you want to say that in this test case, if that happens, it failed. We don't consider it a pass. Even if the application stayed up and healthy, if it goes over this SLA that you have here, fail, and don't release whatever it was you were testing. Now, a little side path here. Things might go wrong. I don't mean, they will go wrong. You're intentionally breaking things. Like, yeah, things are going to go wrong, especially the first few times when things will go wrong in ways that you couldn't have predicted. And so to kind of alleviate the inevitable management question of this, we want to define what we consider both the test failure, which we talked about, and also like, what do we want to do if something goes terribly wrong? At what point do we stop the test and let the system recover on its own? And at what point do we consider this an incident? Because the reality is, the first few times you do this, something's going to break so bad that it will go down. And I always recommend doing it in lower environments first for that reason. But if something breaks and goes down, you learn something from that. So you might not want to declare an incident in dev, but if you're doing this in production, there's definitely going to be a level where you're like, I need to call someone about this. And of course, if you already have defined SLOs, use those because you've already done all the work. Now, one last thing to mention about this slide. You notice that the database deadlocks go 112 versus being different levels. And that's because there are going to be things in production where if they happen even once, that is a problem. Like, let's say you have credit card processing. You can't allow more than one failed credit card process in prod. You might get sued for that. Like, there are legal ramifications for a lot of these things if you're dealing with PCI or PII. So you might want to have some really stringent rules if that's your case. Now, after you've run the test, how do you actually capture those results? There's a couple of ways to do it. If you already have your monitoring tools set up, chances are you can just go into your monitoring tool, find the window that your test occurred, and capture all these metrics from there. But you're basically going to want to capture 4 things. Did the condition occur, right? That's very important. Let's say your condition is an error rate of 10%. If your error rate never got up above 7% during your test, then the condition didn't occur, so nothing should have happened. So you want to make sure that that happened. You want to make sure that the behavior occurred, obviously. You want to make sure that the test conditions were met, like the time box, or the latency, or whatever. And then finally, this is optional, just capture all the metrics that happened during the time for future reference. Latency, error rate, CPU usage, stuff like that. And I always recommend, if you're copying links to your monitoring, that you include the correct time window in the links. Because people will click it, they'll say, I don't see anything, and you'll be like, did you click the link I just sent you? The reality is, they probably just have the wrong time window. So, you've defined your test cases, you've established how you're going to monitor this app and how you're going to make sure the test doesn't blow up, and now it's time to get management buy-in, which is everybody's favorite part of being a technologist. And I'm going to tell you right now that getting people on board to this type of testing is going to be your biggest obstacle. There are very few technical limitations. It's very easy to do this type of testing, but the people need to be on board. And when you go to your manager or their manager or whatever and you say, I'm going to break shit in prod on purpose, they're going to say, absolutely not. So you need to convince them that it's a good idea, because they won't get it right away. So I have a couple suggestions. First of all, as we talked about, accurate and reliable monitoring is the most important thing to getting buy-in. You need to be able to point to your Datadog or Dynatrace or whatever and say, last time this incident happened, we picked it up, but it was too late. And here on our dashboard, I can show you where this metric went crazy. So you can show whoever is concerned, we know if something breaks, we're anticipating that something might break and we're ready for it. So having that monitoring is so important, and being able to demonstrate it is so important. The second thing is, think like a showman. And I mean like the greatest showman, not just like a general showman. I mean like we need to put on a show. We want people to be wowed. So I always recommend the demo that you do to whoever's making the decision should be something with a little bit of a wow factor, right? So find an incident that took down your entire website and see if you can validate that behavior. Something where even someone with zero technical knowledge would see what you're doing and understand the value in the testing. So just make it a show. Come up with a demo, come up with a script, practice the script, maybe get your teammates in on that, and then when you present it, just really give it your all. Like really sell it like you're a salesman trying to sell a product, even though it's something that you built. And then finally, as mentioned, don't use the word chaos. Never even talking to other people in Slack, just don't say it. Just use a term. The new term is reliability management. So if anyone's like, oh, what are you talking about? Say reliability management, not chaos engineering, because it'll scare people away. And as you're approaching this, go from 0 to 1 first. Just go for the low-hanging fruit. Don't put a lot of investment into this. Just try one thing, get it working, and if all you're doing is writing a bunch of one-off scripts for a really long time, that is fine. It's better than nothing. And what you'll find is while you're doing this with your own application, other people will see what you're doing and see the value in what you're doing. And the fact that you've already gotten approval to do this means you've done the hard part, right? Nobody wants to get management approval for anything. So you'll find people coming to you and saying, how do I get in on that? And that is the beauty of this little section here. So you'll be able to not only get other use cases, you'll be able to demonstrate the value of this type of testing in other applications. So let's assume that you have gotten management approval. You got your first test case, you're ready to go, you know what you're doing. That's you, by the way, celebrating your management approval. And so what do you do in preparation for your first continuous verification test? I almost said chaos test, but we're not calling it chaos anymore. First thing, set up an SOS channel. If you use Google Meet or Zoom or whatever, get the URL ahead of time. If you use Slack or Teams, set up the channel ahead of time. And in every single one of your communications about this test, you include those links. And what you tell people is, if anything happens to your app during this testing window, come in here and we'll stop the test. Come into this channel, come into this Slack room, whatever it is, and tell us, and we will stop the test. And that is mostly to reassure people that you understand the risk of what you're doing. You're not just going and breaking shit and hoping it works. You actually know that there might be impact to this, and you're preparing for that. The second thing is notifying stakeholders. So these are the 4 main groups of stakeholders. You probably don't need customer support and executives if you're not doing this in prod, but notify the crap out of those stakeholders. I mean, notify them 2 months in advance, 1 month in advance, the day of, and after the test. This number 3 is so important, people always skip this. After the test is complete, because what will happen is you'll run the test, and then 4 hours later, somebody says, hey, my app is down. Is this your fault? And you know it was not your fault. That test was done 3 hours ago, but they're still going to blame you. So get ready for that. So just warn them when it's done. When you're actually running the test, the first many times you run these tests, stare at your dashboards. Reload your app. If it's a mobile app, reload the app on your phone. Watch the crap out of your app. And it's not just for you, even though it's very reassuring to know that your app is still working. It's the fact that there's going to be somebody expecting you to do this. If you're breaking things on purpose, they're going to expect you to know when it breaks, if it breaks. It shouldn't break. So just constantly be checking it. It'll make everybody happier, and eventually you'll get to the point where you don't need to do that anymore. And finally, every failure, especially in this type of testing, is a learning experience. And I mean that seriously, because if you can break something on purpose by creating some kind of condition that might actually happen in your infrastructure, and it causes a problem, be glad that that problem occurred while you were sitting there watching it, and not at 1 in the morning on Christmas Sunday or whatever, because that's usually when the worst things happen. So if you can do this, and you can prove that it happened, even if you broke something, you prove that it can break, you can fix it. And you can fix it in a controlled manner, not just like, well, now we got a hot fix prod, right? You can actually do it the right way. So it actually is a learning experience. And so that's kind of it for the main content. I want to quickly talk about the tool I'm building, which is FireDrill. I was hoping to have a demo ready, but I got distracted, and I didn't get it deployed, so I don't have a demo for you. But if you want in on the beta, it's going to, I'll explain it to you and everything. hello@firedrill.sh, just send me an email. If you go to the website, I have a video of it working against a WordPress site, so you can see actually how it works. But the idea is, basically, instead of you writing all that glue code, just pay me and I'll write all the glue code, essentially. So you imagine that you have all these different open source tools, and you have all of your tooling, and we just are kind of the glue that sits between those things and makes it so that you don't have to write all that glue code for every single app that you want to integrate. I want to give a special shout out to Undraw.co for all these little drawings. Just a really cool site, and the free commercial use, so I'm like all about that. So that's it. So I know nobody should be scanning QR codes that show up on slideshows, even though I've seen a number of security companies putting QR codes up on slideshows today, which surprised me. But there's my LinkedIn, and that is kind of it. I'm happy to take any questions, or if you want to talk afterwards, that's fine too. But thank you all for attending. I hope you learned something about this today.